Hello guys, it's Johnny time and welcome to another smart contract hacking tutorial. Today we are going to solve the 8th challenge in Damn Vulnerable DeFi version 3, the newest version 2023, and this is the Puppet challenge. So we will go through the whole smart contracts, understand what we need to do, find the vulnerabilities, write the exploit to successfully pass the challenge and practice some smart contract hacking. Now without further ado, let's get started. So this is the 8th challenge for Damn Vulnerable DeFi Puppet. There is a lending pool where users can borrow Damn Valuable Tokens, DVTs. To do so, they first need to deposit twice the borrow amount in ETH as collateral. The pool currently has 100,000 DVT in liquidity. So we have over collateralized lending pool. We need to deposit ETH and then we can borrow 50% of our ETH value as DVT tokens. Interesting. There is a DVD market opened in an old Uniswap V1 exchange currently with 10 ETH and 10 DVT in liquidity. Pass the challenge by taking all tokens from the lending pool. You start with 25 ETH and 1000 DVT in balance. Now everything is makes more sense. So we have this Uniswap V1 exchange. We have a liquidity, and just by reading the description, we might assume and understand that the lending pool, how it determines the price of DVT tokens compared to ETH, and how it determines our collateral and how many DVT tokens we can borrow. Probably it uses this Uniswap V1 exchange pool, which is a very bad idea. Why do you think it's a bad idea, guys? I want you to pause the video, think, and then play it again. This is a very bad idea because Uniswap liquidity pools can easily be manipulated, especially when the liquidity is very low. In that case, 10 ETH and 10 DVT, which means that one DVT starts with 1 ETH. This was going to be the initial price, almost 1 ETH, a bit less because there is some kind of fee, and we also changed the balance of the liquidity pool. But when you understand how DeFi works and how liquidity pool works, with a very small amount of money, we can really change the price between ETH and DVT because the liquidity is very small. That's why it's very not recommended to rely as a price oracle on Uniswap liquidity pools. Now, there are other ways, even if it's not Uniswap V1, to attack the protocol with something called flash swaps. And all these kind of things are more advanced concepts that I cover in the smart contract hacking course. Everything about flash loans and flash swaps and oracle manipulation and such, and deep dive into DeFi protocols. And if you're interested, check out the link in the description below to get a special discount, limited time discount for the complete smart contract hacking course. And yeah, so even if you use Uniswap V2 or V3 with swap oracles, there are still ways to manipulate the prices. So there are different ways to get oracle price. This is the worst of them, getting this spot price of the liquidity pool, and this is apparently what they're doing in this lending pool. And with 25 ETH and 1000 DVT tokens, this is more than enough to manipulate those prices. But before we do that, let's jump into the smart contract and see how the state look like. So in this exercise, we have only one smart contract, puppetpool.sol. We use reentrancy guard address from OpenZeppelin, and we import the Damn Valuable tokens. Now, this is the deposit factor 2, which means we get only 50% of the money that we deposited in ETH. Here we have the immutable address of the Uniswap pair, the token, the DVT token, and a mapping of the deposit. So address and how many tokens, how many ETH actually he deposited. 2 errors, not enough collateral and transfer failed, and 1 event for borrowed when someone is borrowing DVT tokens from the contract. We initialize the contract with the Damn Valuable token and the Uniswap pair address. And we have here 3 functions: borrow, calculate deposit required, and compute oracle price. So let's start with this internal private view function, compute oracle price. This is how they determine the price. How they do it? Like we assume, they take the ETH balance of the Uniswap per smart contract and they multiply it with 18 decimals. Then they divide it by the DVT token balance of this Uniswap pair. So it's the ETH balance divided by the DVT token balance, which is very bad practice, guys. We just need to manipulate the balance of this Uniswap per smart contract in order to completely change the price that this puppet pool think that the DVT token's worth. And how it calculates the deposit required, the amount that we want to borrow, right? This is the amount that we want to borrow in DVT tokens. It takes this amount multiplied by the price that we get back from this function, then deposit multiplied by the deposit factor, which is 2. So if we deposit 2 ETH and 1 ETH is 1 DVT tokens, that we will be able to borrow only 1 DVT token because the deposit factor is 2. This is the deposit required to borrow 1 ETH. This is the amount we want to borrow, and this is how much ETH we need to deposit, right? So this is where the problem relies, the way it calculates the Oracle price, and the borrow function obviously uses these internal functions, this private and public view functions in order to get the price of how much ETH we need to deposit in order to borrow. Now, this is the payable borrow function. We send the amount of DVT tokens that we want to borrow and the recipient address who will receive the DVT tokens. It's payable because we need to send ETH to this function. It's non-reentrance, which means we probably cannot exploit any reentrances here. And this is the deposit required, right? So this is how much ETH we need to deposit in order to get those DVT amount that we are requesting. And if we didn't send it in the message value, then we're going to revert with not enough collateral. Now, if the message value is greater than the required money that we need to deposit, then we're going to send the delta, right? So if the user paid too much ETH for this amount that you want to borrow, we send it so it won't be stuck in the smart contract and it will be fair for the user. And then we just increased the deposit mapping over here, right? So increase the mapping of the user. So we basically log in the contract, in the storage, that he deposited this ETH amount. And we are trying to transfer the token. If it's failed, we revert and we emit an event. Pretty simple, pretty straightforward. Now, how do we screw up with this function? We just need to compute the Oracle price, make sure that DVT worth nothing, and that we can basically send very small amount of ETH in order to borrow all the DVT from the smart contract. We need to do Oracle manipulation attack. We need to manipulate the Oracle price. We need to do an Oracle manipulation attack. And obviously, if you want to learn more about smart contract hackings, ins and out, and all these fascinating subjects of flash loans, DOS attacks, on-chain data, sensitive on-chain data, unchecked returns, Oracle manipulations, front-running attacks, please check out the smart contract hacking course. You get full access to all the materials, all the exercises, an exclusive Discord community with awesome people to learn with them together, to ask me questions, ask other guest teachers questions, a certification at the end that will help you land your first auditor job in a company. So again, check it out in the description below. Now, how do we manipulate the Oracle price? We just need to we don't have to create a smart contract actually, because we don't have any flash loans or flash swap. We don't need to utilize any of those features, but it would be cleaner to create smart contract rather than just sending multiple transactions. So I want to do everything in one transaction, atomic transaction. So my plan is to create a smart contract that just dumps all the DVT tokens that I possess as the player to the Uniswap pool, basically decreasing the DVT tokens down, the price down in front of the eyes of the pool contract, then requesting to borrow all the DVT tokens after we dump them to the Uniswap pool and reduce the price, and we can borrow them almost for free because the price is so low because we manipulated the price by dumping those tokens to the Uniswap pool. Now, this is the Puppet Challenge JavaScript file. As you can see, these are all the constants, the initial liquidity in the Uniswap pool, the player initial token. It's everything that was described in the exercise description. Here we have the signers. We deploy the contracts, send the tokens to all the accounts, do some just checks, just expectations, unit tests, that the tokens liquidity is this, and the pool has these tokens, and the player has these tokens. So this is just setting up the exercise. Here we need to run our exploit, and this is the state that we need to achieve. We need to achieve three things. First of all, we need to execute everything in a single transaction, which I will give you a spoiler alert. It's not really possible unless you use another signer. This is some kind of error of the exercise creator, I assume, but we will bypass it in a very creative way. We need them to take all the tokens from the pool. So the pool token balance should be 0, right? And we need to make sure that our token balance, the player account token balance, is greater than the pool initial balance. Or in other words, we were able to steal all the tokens from the pool. Now, how are we going to do it? First, we're going to create a new smart contract. So under player contracts, I'm going to create a new contract, attack puppet.sol. This is going to be our malicious smart contract. Let's just copy this few lines of code, the Solidity version, and let's define a new contract. I will call it attack puppet, right? So this will be our contract. We will have a constructor. The constructor need to receive 2 parameters that we will need to work on. The first one is the address of the token. So address of the DVT token, so we'll do token, and the address of the Uniswap pair, right? The pair. Now, since we have to deal and send transaction to token, I'm going to import the IERC20 interface from OpenZeppelin because I will need the interface functions to the SIG hash of the functions to send transactions and send tokens, basically. And I will also need to define some interface for, first of all, the interface for Uniswap exchange V1. We will have to swap the tokens through the smart contract. So we will need to define this interface and add the swap function. So I'm going to go back to the Uniswap documentation over here to the exchange section, and I will search for swap to see how the swap function look like. This is ETH to token. I need token to ETH because we want to dump the DVT token to the pool. So let's search for token to ETH. Perfect, right? So we need this one, token to ETH swap input. We want the tokens. We send the tokens amount that we want to sell. We set the minimum amount of ETH that we are expecting, the deadline and the recipient. And this is how we sell these DVT tokens to the Uniswap pool. So I'm gonna copy this one to my interface over here. So this will be the function. Let's just copy it. And I will just change it to function, and this will be, oh, it's completely horrible. I will do just function and copy the name over here to function, and it will receive this uint 256 of tokens sold. How many tokens we want to sell? uint 256 of, it's all uint 256 apart from the last one, min ETH, and it will be uint 256. This will be the deadline, and again, it will be address, the last one, address of the recipient. This will be the address of the recipient. Awesome. And this function is what? Let's see. It's an external function that returns uint 256. Awesome. Okay, we have the interface for the Uniswap exchange. Let's create the interface for the pool, right? Because we also have to interact with the pool through our smart contract. So we need to interact with the borrow function. I will copy it and I will create a new interface iPool. And let's write this thing here, external payable. Awesome. We have interface for the pool. Now it's time to define the state variables. So Uniswap exchange, immutable. Let's call it whatever, exchange or pair, doesn't matter, exchange, right, exchange. Now the token IRC20 immutable, this will be the token, and we need also to define the pool. So iPool immutable, and it will be the pool. We also want to make sure that only the player can operate the smart contract, and we also want to send the tokens eventually to the player. So we'll define here address immutable, and it will be the player account. Awesome. Okay, so we have all the variables. Let's set them in the constructor. So token equals IRC20 of the token address. Same for the exchange. We actually need the pool as well. I guess we do need a pool. Yeah, we do need a pool. So we have the address of the pool as well. Awesome. So this is the token. Then we have the exchange is equals the Uniswap exchange of the pair address and the pool. So the pool equals iPool, and this will be the pool address. Beautiful. And the player is obviously the message.sender, the one who deploys this particular smart contract. Now let's define our attack function that will make all the logic to come true. So it will be function attack, and it will be external, and it will be payable because we will need probably to send the ETH to this function to maximize our liquidity and our fortune to execute the attack. So we're probably going to send ETH. We can also send it here in the constructor, but I prefer just to send it right to the function. The first line of code will be some kind of access control. So we make sure that the message.sender is the player. So no one else can actually initiate the attack, only us, the one who deployed the EO account that deploys the contract. And now let's plan our attack. So first we need to do what? We need to dump DVT to the Uniswap pool. So we will have to transfer the tokens in advance from the EO account to the smart contract. We'll do it in a JavaScript code, but now we assume that we already have the tokens. And in order to dump them to the Uniswap pool, first we need to approve the pool to spend our tokens because it's going to use the transfer from function. So what I'm going to do is token.approve, and I will approve the address of the exchange to spend how many tokens. Let's think how many tokens, DVT tokens, we want to dump into the pool. And by the way, if you're not familiar with ERC20 tokens and Uniswap, again, the smart contract hacking course is gonna make sure that you master those things like I sync them, the approve function, the transfer form, Uniswap, liquidity pools, exchange, pairs, everything is going to be covered there. So check it out. Now, how many tokens we want to sell to the pool? We want to sell all our DVT tokens. We don't care. We just want to dump them all to dump the DVT token price. So 1,000 DVT tokens, right? Let's define it here in a constant. So it will be more beautiful, sell DVT amount, and it will be, this amount is going to be 1,000 Ether. Ether is actually just a keyword for 18 decimals, so it could be, let's just define here uint 256, uint 256, constant. This Ether is basically like doing multiply by IE18, right? So it's 18 decimal numbers. You can just use Ether, which is by default gonna be 18 decimal numbers, right? So now we can use this constant amount that we defined to approve this amount of tokens, and now we can actually swap the tokens. So we'll do something like exchange.token to ETH transfer input. And I love tab 9, it always auto-completes me, but this time we just bullshit parameters. So this should be the token sold, should be this amount. The minimum ETH that we are willing to receive, I would say I want all the 10 ETH, but if it will be 10, we are not able to actually, the Uniswap will never allow us to get 10 ETH, so I will just be fine with 9 ETH. The deadline, not safe practice, not best practices, but just because it's an exercise, so I'm going to do block.timestamp. And the recipient is going to be obviously the address of this smart contract. We want to receive the ETH after the swap. Now, this is not safe to do because it's for another video, okay? I covered it in other videos why it's not safe to give the deadline as the block timestamp. If you want to learn more, follow this channel, learn about all the different kind of vulnerabilities that we have in smart contracts. But we want to receive the ETH to this smart contract because we want to use this ETH to borrow or steal all the DVT tokens from the pool smart contract. Now, in order to receive ETH in this smart contract, we need to make a receive default fallback function. So I'm going to define here receive, and it will be external and payable function. So this contract now is able to receive ETH from the Uniswap smart contract. Awesome. Now that we dumped the DVT tokens to the Uniswap pool, we got the ETH. We're going to use all this ETH that we have in order to basically get the DVT tokens from the lending pool that is vulnerable to Oracle manipulation price. To call the borrow function, first we need to determine how much ETH we need to send, how much is the deposit required, right? We don't want to send too much ETH. We can actually send all the ETH and receive the change, but it's not required, right? I want to calculate the exact numbers, so I'm going to use this exact same code in my smart contract to calculate the Oracle price after we did this manipulation and how much collateral we need to deposit. So I'm just going to copy this line of code and do something like uint256 price. I will add here a comment, calculate required collateral. Right? So the price is going to be this calculation, but we just need to change it. Instead of Uniswap pair, it will be the address of the exchange smart contract. And this will be tokens balance of the address of the exchange. So we just duplicated the same functionality to get the price. And we also create the same thing for the deposit required. So uint 256. And let's do deposit required. So this is the amount of ETH we need to deposit. And we're just going to do this thingy. Now let's see the parameters. So compute Oracle price. We don't need to call this function. We have the price already here, so we can replace it. The deposit factor, we already know it's 2, but we can actually just copy it as a constant in our smart contract. So we will do it here. This is the deposit factor. We have it also in our malicious smart contract. And the amount. The amount is the amount of DVT tokens that we want to borrow from the pool. Now, how many DVT tokens we want to borrow from the pool? Simply all the tokens, right? All the tokens that exist in the pool. We want to ask how much ETH we need to pay. So we have $100,000, 100,000 DVT tokens. So we will create another constant and uint 256 constant, and this will be the borrow DVT amount, and it will be basically 100,000 of Ether because it's 18 decimal numbers. So this is the borrow DVT amount, and this is the amount that we want to calculate how much ETH we need to deposit in order to get this amount, right? Now that we know the deposit required, we can make the external call to the borrow function. Okay, so we simply just gonna call we'll just add some comments, borrow, and steal the DVT. So we're just gonna do pool.borrow, and we are gonna borrow this borrow DVT amount. This is the amount that we need to borrow, right? The first parameter is the amount, and then it's the recipient. So it's going to be the borrow DVT amount, and the recipient, we can actually already send the player address. So it will be the address of the player account. Well, actually, we don't need to wrap it with address because it's already an address. And here we'll have to send the ETH, because if we don't send the required ETH, our transaction will be reverted, and we already know what is the deposit required. So this is just going to be here, right? This is the ETH that we're going to send to the smart contract and get the DVT tokens directly to our player account. Now we need to make sure that we have this ETH amount in the smart contract. We get some ETH in exchanging the tokens, but it's probably not going to be enough because we have only 9 ETH. We don't know exactly what is the deposit required. And if you want to learn more about the attack, I actually recommend you to add the hardhat console log library. So it looks like this: hardhat console.sol, sorry. So now we can use console log inside our smart contract, and it will be very interesting to log certain things. First of all, I want to log the ETH address balance after the swap. So I will do console.log, and it will be a contract ETH balance after the swap, and we're gonna also send some ETH to the smart contract through this payable function. So it will be address this dot balance, and we also want to log the DVT price. What we were able to do it after we dumped the DVT tokens to the Uniswap pool. So I'll do DVT price, and here it will be the price. And we also want to log the deposit required. So console.log deposit required, deposit required. And this will be the deposit required parameter. So now when we run the test, we can actually get some information about how we were able to affect the contract and the pool, the price, the deposit required. Beautiful. And now it's time to deploy our malicious contract and initiate the attack. So the first thing I'm gonna do is just get this factory of the attack puppet smart contract. So I'm just gonna paste this line of code. This is our smart contract, and we're going to deploy it from the player account. So let's deploy the smart contract. So I'll do this dot attacker contract, and it will be await attacker contract factory dot deploy, and let's deploy it with those three parameters. The first parameter should be the token, so it will be the token dot address. The second one is the Uniswap exchange. I guess it's the exchange. Yeah, the exchange, the pair. So it will be Uniswap exchange.address. All these, by the way, all these parameters already exist for me here in the setup, so I can just use them. And then the third one is the pool. So it will be pool. What's the name of it? It will be landing pool.address. Awesome. We deployed our malicious contract with these three addresses. And now, what do we need to do? First, we need to send the DVT tokens to our smart contract before we call the attack function, because here we already assume that we have them in the contract. So I will do token.connect player, and I will just transfer the tokens to this.attacker contract.address, and the amount of token that I want to send is all my DVT tokens, which is my player initial token balance, right? So let's just send all the initial balance to the attacker contract. Beautiful. The next thing I want to do is call the attack function, and I want to send some ETH to the attack function, actually all my ETH, so it will be able to use it later on to drain the puppet pool, because the ETH that it will get from the swap on Uniswap probably won't be enough. We can try to do it without ETH, but it will probably fail. We can see how much ETH is required and then send the delta ETH that is missing after the swap. So let's first just call the await this.attacker contract.attack, and that's simply it. Now I need to send here some kind of value. Let's try to call it initially without extra ETH that we sent to the contract, and let's try to run the test and see what happens. So I will do yarn puppet. Now it probably failed, yeah, and it failed, and we can see what actually happens, because we have around 9.9 ETH in the balance of the contract, because we swapped the tokens, we sold the DVT tokens, we got the ETH from the Uniswap contract. Now the DVT price is significantly lower, as you can see. It's with less decimal numbers, it's 0.000 something ETH, because we dumped everything to the pool, but the deposit required is still around 20 ETH, which means that we need to send this extra ETH to our malicious smart contract, so we will be able to get those DVT tokens from the lending pool. And the delta is around 1.03 ETH. So I'm just gonna send 11 ETH. We start the exercise with 25 ETH, so I will just send 11 ETH to the smart contract, because I'm not gonna calculate this right now. So value, and we're gonna send 11 ETH. So I will just take this number, right? This is going to be the number, and I will change this 10 number to 11. So I'm calling the attack function together with 10 ETH. So we'll have enough ETH to drain all the DVT tokens from the pool. Let's try to run the test again and see what happens. All right, guys, we had a small stupid mistake. I used this.player instead of player. So I didn't deploy the contract with a player account. So I just fixed it. So instead of this player, it's just player. And now we have another issue. If we run yarn puppet, basically the first requirement fails, right? So the first requirement over here fails because we want to do it only in one transaction through the player account. This is the requirement of the exercise, and we can simply just change it to 3, but it will be cheating, so I will cheat it in another way. I'm just gonna use another signer to deploy the smart contract, and I will just use one transaction from the player to send the tokens to the malicious contract, but the contract himself will be deployed with another signer. So I will get a new signer. I will get the third signer from Hardet, and I will call him this.player2 because I can see that the first two signers are taken for deployer and player. So I'm gonna just take the third one as player 2. Now this malicious smart contract will be deployed from player 2. Okay, I will send the tokens from player 1 because he's the one who possessed the tokens, and I will call the attack function. Now, obviously, the tokens will be sent to player 2, so I will need to send them eventually to player 1. So I will do something like await this dot token dot connect. I will connect this player 2. I will send transaction from player 2, and I will call it transfer function. I will transfer all the balance to the player address. So the recipient will be the player address, and the amount will be await token dot balance of this will be this dot player 2. So we basically execute the attack from player 2, but we send the tokens from player 1, and eventually we send the DVT tokens to player 1 to meet all the conditions of one transaction of player 1, and player 1 has all the money at the end. And now it's the money time to run the test and see if we're able to pass the challenge. So yarn puppet, cross your fingers, guys. No, we failed. All right, we had a small mistake, so it's instead of this token, it's just token. So let's run it again. And this is token balance off and not token dot balance. Yeah, and the last error is that we need to pass the address of player 2 to the balance of function. So let's run it again. And we made it, guys. Finally, it was a long process, but we learned so much, guys. We were able to drain all the pool by manipulating the Uniswap price. And this was an amazing exercise to learn about Oracle manipulation and why you should not rely on Uniswap liquidity pools for Oracle prices. If you enjoyed this video, consider smashing the like button and subscribing for more awesome smart contract hacking and auditing content. Thank you so much, and I will see you in the next one. Bye bye.